Hello, greetings to you all. Welcome back to the course in Data Communication and Networking 1. In the last lesson, we ended the lecture on uh, components of data communication. The five components of data communication. We talked about message, we talked about sender, we talked about receiver, we talked about transmission medium, and we talked about the protocol, right? And we ended the class. Today, we would like to start with today's lesson on data representation. Data representation. So let's look at it. Data representation. Okay. So let's do this. Let's increase our font size so that it can be much more clearer. Okay, data representation. Yeah. So first and foremost, when we talk about data representation, what we mean by defining this word, we are trying to say the different ways data representation can be defined. Okay. Can be defined as the different ways data can be represented. Okay, it can be defined as the different ways data can be represented. Another way you can define that also, we can say it can also be defined as a form, a particular form for which data can be represented. We can also define it as, it can also be defined as the different forms data can be identified by. Okay, and so on and so forth. So we can define it in these different ways. So let's put it this way. Remove this. Okay, yeah. Then we'll come here and make this also a point. Let's put it in pointer point. It can also be defined. So far we have said it can be defined as different ways data can be represented. It can also be defined as a particular form for which data can be represented. It can also be defined. Okay, we are using also. Okay, let's remove the also from here. It can be defined as the different forms data can be identified by. And let's add additional. It can also be defined. As the different forms, or as the form let's not use the word form again, because we want to use different words to define that will carry all the same meaning. Okay? It can also be defined as data representation can also be defined as a way of or as the different categories for which data exists. It can also be defined as different categories for which data exists. So this is data representation. So we're going to look into them one by one. So we'll start by saying information today. Let me leave space. Information today comes in different forms, such as text, numbers, images, audio, and video. Information today comes in different forms, such as text, numbers, images, audio, and video. So these are the different forms of data representation. These are the different ways in which data can be represented. So let's take them one by one. So let's take the first one. One, text. Okay, so let's talk about text. So the first one we said text. So let's look at it. In data communication, text is represented as a bit pattern. A sequence of bits. That is, so let's put that in bracket, zeros and ones. Okay, the different sets of bit patterns have been designed to represent text symbols. Each set is a code and the process of representing symbols is called coding. It's called coding. Today, the prevalent coding system is called Unicode. Unicode, which uses which uses 32 bits to represent a symbol or character. Used in any language. Used in any language in the world. Used in any language in the world. The American standard code. Let's put this in caps. The American standard code. Which is ASC, capital ASC in brackets. For information, interchange. For information interchange. Information interchange. Okay, so let's take this from here. The American Standard Code for Information Interchange. So we'll bring that here. So it's gonna be ASCII. ASCII. Okay, developed some decades ago. Developed some decades ago in the United States. Now constitutes the first 127 characters in Unicode. And is also referred to as basic Latin. So let's look at what we have written down so far on that text as a form of data representation. So we said so far, in data communication, text is represented as a bit pattern, a sequence. Now we're defining a bit pattern now, which is a sequence of bits. Okay, a sequence of, the bit pattern is a sequence of zeros and one. 0 1 0 1 0 1 0 1, 1 0 0 1 1 0. So that is the pattern. Okay. Now we went on to say different sets of bit patterns. Now when you have a set of this particular pattern, have been designed to represent text symbols. So that's to tell you that if, for example, you want to create a particular symbol, you will have to have a combination of different sets of bit pattern. Each set is a code. So each of these sets now is a code. And the process of representing symbols is called coding. So whenever you create a symbol through the use of a combination of several sets of bit patterns, what you are creating or what you are doing is basically coding in the context of data communication. Okay, or under the context of data. Now, we went on to say today the prevalent coding system is called Unicode. This is the prevalent one that is being used today. And they give you some of its characteristics. As they went on to say, it uses 32 bits to represent a symbol or character used in any language in the world. Okay? The American Standard Code for Information Interchange, ASCII, developed some decades ago in the United States, now constitutes the first 127 characters in Unicode, and is also referred to as Basic Latin. So this is how we will talk about the text. So this is a form of data representation. So now we'll move on to the second one. The second one now is numbers. Numbers. Numbers are also represented by bit patterns. However, a code such as ASCII is not used to represent numbers. The number is directly converted to a binary number binary number to simplify mathematical operations. Okay, so this is all you need to know about numbers. Numbers are also represented by bit patterns. However, a code such as ASCII is not used to represent numbers. The number is directly converted to a binary number to simplify mathematical operations. So that's the second one. The third one now, images. 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 Images are also represented by bit patterns. Full stop. In its simplest form, an image is composed of a matrix of pixels. Otherwise known as picture elements. Otherwise known as picture elements. Where each pixel is a small dot. The size of the pixel depends on the resolution. Depends on the resolution. For example, an image can be defined, or rather divided, into 1000 pixels. To 1000 pixels, or 10,000 pixels. In the second case, there is a better representation. It's a better representation of the image. Otherwise called better. Otherwise say that is a better resolution. But more memory is needed. Now, after an image, is divided, into pixels. Each pixels is assigned a bit pattern, as we said earlier. Is assigned a bit pattern. The size each pixel is assigned a bit pattern. Okay. The size and value of the bit pattern to include the size and value of the bit pattern depend on the image. Depend on the image. So that is that on images. For the next one, audio. Audio refers to the recording or broadcasting of sound or music. Audio is by nature different from text. Text, numbers, or images. It is continuous. It is continuous. Not discrete. Even when we use a microphone. To change voice or music to an electric continuous. Create a continuous signal. So that is on audio. The fifth form of data representation is video. Video refers to the rendering or broadcasting of a picture or movie. Video can either be produced as a continuous entity e.g. by a TV camera. By a TV camera, or it can be a combination of images. Each a discrete entity arranged to convey the idea of motion. Again, we can change video to a digital or an analog signal. To an analog signal. So let's go through all of the things we have listed so far under data representation. Let's go through it briefly before we conclude the lesson for today. So from the beginning, we gave different definitions of data representation. We said it can be defined as the different ways data can be represented. It can be defined as a particular form for which data can be represented. It can be defined as the different forms data can be identified by. It can also be defined as the different categories for which data exists. Okay. Then we went on to discuss further by saying information today comes in different forms, such as text, numbers, images, audio, and video. We wrote short notes on each one of them, explaining further their characteristics and things that we needed to know at this moment regarding them. So the first one we wrote down is text. And we said in data communication, text is represented as a bit pattern, a sequence of bits from zeros and ones, or between zeros and ones, 0, 1, 0, 1, 0, 0, 1, like that. Different sets of bit patterns have been designed to represent text symbols. So these bit patterns are designed to represent a particular symbol. Now each set is a code. Each set of these bit patterns is a code. And the process of representing symbols is called coding. Today, the prevalent coding system is called Unicode, which uses 32 bits to represent a symbol or character used in any language in the world. The American Standard Code for Information Interchange, ASCII, developed some decades ago in the United States, now constitutes the first 127 characters in Unicode and is also referred to as Basic Latin. So these are the things we need to know. These are the essential things we need to know about text as a form of data. The second one now, numbers. We said numbers are also represented by bit patterns. However, a code such as ASCII is not used to represent numbers. The number is directly converted to a binary number to simplify mathematical operations. So you see that there is a contrast between text and numbers, and there's a difference also. Even though we said they are represented by bit patterns, we can see numbers don't use the same form of bit patterns as text. That's why we said, however, a code such as ASCII, which is what we mentioned under text, is not applicable or cannot be used to represent numbers. Rather, the number is directly converted into a binary number to simplify mathematical operations. So, binary numbers. 3. Images now, the third form of data representation. Images are also represented by bit patterns. In its simplest form, an image is composed of a matrix of pixels, meaning picture elements, where each pixel is a small dot. The size of the pixel depends on the resolution. The size of the pixel depends on the resolution, meaning if the size of the pixel, if the resolution is big, okay, the size of the pixel will also be big. So the size of the pixel depends on resolution. So depending on what resolution you are using a higher resolution device or a lower resolution device, will determine how much pixel will be required. Okay. For example, an image can be divided into 1,000 pixels or 10,000 pixels. So they are telling you now, an image can be divided into 1,000 or 10,000 pixels. So we are going to differentiate between these two now. Images that are divided into 1,000 pixels. What happens to them? How do they differ from images that are created with 10,000 pixels? Are they the same? Is there any differences? Okay, so let's go look into that. So in the second case now, they are telling you there's a better representation of the image. There's a better representation of the image that is better resolution. Remember, we are saying when you are talking about pixel, the pixel is what makes the image become so clear or less clear. So that pixel is dependent on the resolution. So when you have a better resolution, you also have a better, and it requires a larger pixel. Okay, but when you have a lower resolution, also what will be rendered to you on the screen will be a lower pixel. So here there's a highlight to tell us that in the case of 10,000 pixels, there is a better representation. So the higher the pixel, the better the representation, meaning the image that is going to be displayed to you is going to be much more clearer. It's going to be much more of high quality. Okay, that's what it is meant by better resolution. Okay, but more memory is going to be needed in this situation. You want much more clearer image with a high resolution. So for you to be able to get that, you should be able to have a device that's carrying a much more higher storage for it, because it will require a much more higher storage. Now, after an image is divided into pixels, each pixel is assigned a bit pattern. So the first thing that happens is that an image is divided into pixels. Now each of these pixels is assigned a bit pattern. So a combination of pixels will give you a set of patterns. Okay. The size and value of the bit pattern depend on the image. Now again, there's emphasis on the size and the value of the bit pattern, and it's been emphasized that it depends a lot on the image. Okay. So if the image is of high resolution, high quality, then it means the bit pattern the bit pattern is higher, and also the size of the file, of the image file, is going to be high as well. So this is all that is essential for now to know regarding images. Now we move on to the fourth category or form of data representation. The fourth one, audio. And we said audio refers to the recording or broadcasting of sound or music. Audio is by nature different from text, obviously, numbers or images. It is continuous, not discrete, otherwise not static. We can use that simultaneously to mean, for those that may not understand what we mean by being discrete. Being discrete means something that changes, right? So in this kind of situation, we are saying audio is not static, right? It's continuous. It keeps moving. It keeps counting. Okay, it's time bound. We can put it that way. It's time bound. Even when we use a microphone to change voice or music to an electric signal, we create a continuous signal, and that is the audio we are talking about. Okay, I want to believe this is clear now. The fifth one, video. Similar, but this one is going to be a combination of both image and audio, and image emotion, or rather you will say, how do you put that? Okay, let's read what we wrote down. We said video refers to the rendering or broadcasting of a picture or movie. You see, refers to the rendering or broadcasting of a picture or movie. Video can either be produced as a continuous entity, e.g. by TV camera, or it can be a combination of images, right? Each a discrete entity, arranged to convey the idea of motion. Again, we can change video to a digital or analog signal. So basically what's being said here is to tell you that a combination of images that are time bound, okay, can be used to form a video. That is one way, which is the way that is being highlighted here, where you have a series of pictures, and in that video, more like a slide. We call this a slideshow. Slideshow is a form of a video representation. It's also, we call it a video because obviously you have movement of images that are time bound. Okay, so each of these images, when they say each a discrete entity, basically they are trying to tell you that each image is on its own. Okay, each a discrete entity on its own and does whatever it is assigned for, arranged to convey the idea of motion. So these images are arranged to convey the idea of motion. So you can imagine taking a photo while you are standing, taking one photo while standing, taking one photo while taking one step, and like that. If you combine all of these steps in motion, it will look like a real video, like truly the person is moving, because now we have bring these images together, and that's what you see most of the time when images are snapped in motion. Somebody is moving like this, and moving like this, and moving like this. If you put all of it together and make them time bound, it will create a video for you, or you will get a video as a result. Okay, so these are the different forms of data representation we have under data communication. Okay, so I would like to end the class here. See you in the next lesson.